Hello my dear students, this is Akash SD and welcome to the ASD Physics classes. Hope so you are doing really great. So students, in this video we are going to learn electric potential due to multiple charges, and we are going to also learn what is the principle of superposition and how this is important in physics. Okay, so let's start the video. So students, you can see very well the first topic is what you can see. The first topic is electric potential due to a system of charges. System of charges means multiple charges will be there, maybe 2, 3, 4, but actually 2 or more than 2. Okay, so let's see please. According to principle of superposition, electric potential at a point O due to charges Q1, Q2 and Q3 is given by. Okay, so first what we'll do here, let's take here I have taken charge Q1 here, I have taken charge Q2 here, and I have taken charge Q3 here. Okay, even here I have taken all the charges positive, even mixed charges can be also possible, some positive, some negative. Let's take here I have taken minus Q3. Okay, so here also I have taken minus Q3, no problem. Yes, student. So what will happen that here, let's take for example here I have taken point O. Now, so at point O, you know how many potentials will be there? 3 potentials will be there. One due to Q1, another one due to Q2, and next one due to Q3 here. Okay, so students here, let me take here, this distance is R1, this distance is R2, and this distance is R3. Okay, so now electric potential at point O will be due to 3 charges. Now remember that very carefully. When we are calculating potential at point O due to charge Q1, the presence of Q2 and Q3 does not matter. Similarly, let me write here, that means potential at point O due to 1 plus. Now, potential at point O due to charge Q2 will be unaffected by the presence of Q1 and minus Q3. So, what will become here? V02 plus. Similarly, potential at point O due to charge minus Q3 will be unaffected by the presence of Q1 and Q2. That means we can write here V03. So, if we add all of them, now then we'll get the potential at point O due to the 3 charges. This is the only called principle of superposition. Okay, so students, if I write here even the values also, I can tell very well. K Q1 by R1 plus K Q2 by R2 plus K minus Q3 by R3. Okay, so this is the potential. Now students, you know at point O potential is there, and at the point O electric field will be also there. Okay, so whenever in electrostatics any point is there, their electric field is also defined and potential is also defined. Okay, but you have to remember that one thing. What is the possibilities there to the remember? Kindly see please, see. Any of the following possibilities may exist at a point due to a system of charges. And students, what are the possibilities are there? See please. First possibility, when at any point E equal to 0, then V may not be 0. Similarly, if E is not 0, then V may be 0. Similarly, when E is 0, V may be also 0. And when E is not equal to 0, then V is also not equal to 0. Okay, so any of the 4 possibilities may exist. So what I am telling here, kindly listen very properly. If at any point potential is 0, then electric field may be 0, may not be 0. Okay, similarly, if at any point electric field is 0, then potential may be 0, may not be 0. Now, depending upon the situation, what is the charge configuration? What is the charge configuration in a system of charges? Okay, all this we are going to learn by the some examples and some cases. Okay, students, so let's move to the some cases here. So, here students, cases of electric potential. Case 1, we are going to see system of 2 charges. Okay, students, so see please here. Here I have taken charge Q, and here also I have taken charge Q, and this is, let's take for example the center is there. Okay, and let's take this distance is A, this distance is A. So as we are seeing the potential, first we'll see potential at point O. So you know very well potential at point O will be due to how many charges? 2 charges. Let's take this is charge 1 and this is charge 2. Means charge QQ, but I have taken the points point 1 and point 2, or position 1, position 2. So what will happen at here? At point O due to position 1, it will be how much here? KQ by A plus KQ by A. You can add and all, no problem. But anyhow, we understood that potential at point O is not 0. Okay. Now after that, if I see the electric field here, electric field, now see here please. At point O, if I see the electric field, can you guess very well what is the electric field at point O? Now, if I talk about here this, due to this charge, electric field will be always away from the positive charge, that means in this direction here, okay. Let's take for example, I have told here 1 na, so here E1. Similarly, here due to this charge Q at position 2, electric field in which direction? Away, in this direction. And you know very well here, charge is same, distance is same, so both this electric field will be what? Cancel out here. And anyhow, what will happen that here electric field will be 0. So you can see here at point O, what situation we have got? Potential is not 0, but electric field is 0 here. Okay, this one I have taken, let's take A. Okay, now students, B. I'm just seeing the possibilities, and in this way we are learning also. Okay, how to calculate the potential and all that. Next one is students, let's take for example here. Here I have taken point Q, and here I have taken means minus Q, plus Q, and here this is the center O. Okay, so you can see very well what is this? This is the electric dipole. Here A, here A. Even the question came in an exam, competitive exam. At point O, they will ask what is the potential, what is the electric field. Okay, student. So can you tell me here? Again, let me take here. This is 1, this is 2. Okay. So potential at point O due to charge at position 1 is given by K minus Q by A, plus potential at point O due to charge at position 2 is given by K plus Q by A. That means what you can get here? We can get here potential at point O, how much? 0, 0. Okay. Even students, I will just tell you here, even if you take any point here on this line, this is called the which one? Equatorial plane in a dipole, you know very well. So if you take any point, maybe here, maybe here, maybe here, any point on this line, what will happen at all the points? Potential will be 0. That we have learned. Equipotential, not equipotential, electric potential at the equatorial point of the dipole. Okay, so anyhow potential will be 0. Now students, after that, if I talk about the next one here, now if I talk about next one here, electric field. Do you think electric field at point O will be 0? Anyhow we can calculate, no problem, but we want to identify whether electric field will be 0 or not. Okay, so see please students. Now due to this charge minus Q, electric field in which direction? Away or towards? Away or towards? Towards, in this direction. Is it? Let's take, I am telling here this is E1. Similarly, this is positive charge. Due to this positive charge, electric field at point O in which direction? Away or towards? Now it will be away. So here you can see very well students here. In this situation, both the electric fields cancelled out. But here what will happen? Both the electric fields will add up, and anyhow electric field will not be 0. Okay, calculation and all we can do, previous videos are there. Okay, so here we have got this possibility. Potential is 0, but electric field is not 0. Okay, now students, I will take here, this is C situation. Now again I have taken here, this is minus Q, this is plus Q, dipole only, na, because this also used to come in exam, so only I have taken the example of the dipole here. Okay, now students, let's take for example here, I have taken here some point A. Okay, this is which point? Guess and tell me. This is the axial point, axial point. So students, you know very well here, in this situation, if I talk about here, potential at point A. Potential at point A will be how much? Due to positive charge also, due to negative charge also. Okay, let's take here this distance A, this distance also. So we can write here due to negative charge, K minus Q. You can take here, this is position 1 and this is position 2. Which one? This one. This one I have taken, this is position 2. Okay. So K minus Q by how much? R plus A plus K into plus Q by R minus A. Okay, so students, when you will simplify this, anyhow what will happen that here you can simplify and all, but I can tell definitely very well potential at point A you have to remember also, but okay, I'm writing here K into P by R square minus A square. P is the dipole moment, P equal to 2AQ. Okay, but my main point of concern is that I want to tell you potential at point A is not 0. Okay, that we also know very well. Okay, now next one. Similarly, if I talk about the electric field at point A, can you guess very well? Electric field at point A, I will just write the formula for you. K into 2P R by R square minus A square whole square. Okay, if you put in a vector form also like this. Okay, that means electric field at point A due to negative charge also, due to positive charge also. Okay, and this derivation and all I have covered also before. But my point of thing is that electric field is not 0. So here you can see I have shown you the 3 situations. Here in first A situation, potential is not 0, electric field is 0. Here you can see potential is 0, electric field is not 0. And here potential also not 0, electric field is also not 0 here. Okay, so this thing we have to remember that here we have seen which one? System of 2 charges. Okay, next one is students, we are going to see system of 3 charges. System of how many charges? 3 charges here. Okay, so let's take, I have taken A here, and let's take here, this I have taken charge Q, this I have taken charge Q, and this also I have taken charge Q. Okay, even if I want, if you want that, okay, we should give the numbers also to make it very easy. Let's take here 1, 2, 3. Okay, so students, now I want to calculate this one here, this one here. Okay, here potential at point O and electric field at point O, how much here, and this distance, let's take, I have taken R. Okay, students, so tell me please here, potential at point O due to charges will be how much here? Due to charge Q at position 1, K into Q by, can you guess me, this distance will be how much here? Charge to the observation point distance, you have to remember that here. This distance we have done before also, but R by root 3 you have to remember that here. So what will become here? R by root 3. Like this, due to this charge also same situation, due to this charge also same situation, that means we have to multiply with 3, and what this will become here? K into 3 root 3 Q by R. Okay, so the concern is what? The concern is what? Anyhow, the potential is not 0. The potential is not 0. Potential is not 0. Okay, this one we have got here. Now after that, students, next one if we see here, if you talk about here the electric field at point O, they are asking question like this in the exam. Okay, now electric field at point O will be how much here? Electric field at point O will be how much here? See, due to this positive charge, electric field away this side. Due to this positive charge, electric field away this side, and due to this positive charge, electric field is away this one here. All situation is same. Okay, so electric field will be all same here, and you know all these angles will be how much here? All these angles will be 120, 120, 120. Okay, and in a very basic level, all these 3 vectors will make closed polygon in same order, and their resultant will be 0. Or even you can tell from the Lami's theorem also, electric field will be how much here? 0, because all these 3 vectors will cancel out here. Okay. So in this situation, you are seeing that what is there? Potential is not 0, but electric field is coming 0 here. Okay, now students, let me take care of this situation. Now I have taken here, students, now here, let's take, students, I have just taken here I have taken charge 2Q, here I have taken charge minus Q, here I have taken charge minus Q. Now just for the, discuss the possibility here. Okay, so see here please. Okay, so again, let's take here this distance, how much here? R by root 3, R by root 3, R by root 3. Okay, anyhow, this is R. Okay, so students, can you guess very well what is the, this is the situation B actually. Okay, so what is the potential at point O? Now you can guess very well. So what will become here? K into 2Q by R by root 3 plus K into, how much coming here? Minus Q by R by root 3, okay, plus K into minus Q by R by root 3, because you know very well the summation of the charges is 0, and this point O is symmetrical to the charges. So anyhow here potential is coming how much here? Here potential is coming here 0. Here potential is coming here how much? 0. But if I talk about here the electric field, can you guess and tell me electric field at point A will be 0 or not 0? Is it? So see please. This is minus Q charge. Electric field is towards here. I have taken here E. This is minus Q charge. Again, electric field is towards here E. Okay. And now this 2Q charge is there. 2Q charge. Again, electric field is away. Okay. So distances are same only. So I can tell here this is E, this is E. So 2Q charge is there. What I can tell here? This I can tell here 2E. Now you know what will happen that students, this E and E is making how much angle? No? Anyhow, electric field is not 0 because you can see even, but I will just tell the value also even here. Okay, so this E is making how much angle? This angle is 120 degree here. Okay, so when you will see the resultant, that will also come E, and then this 2E and E will add up in a vector form here. But anyhow, what will happen that here? Electric field at point O is not 0. Okay, so here also I have shown you the situations, potential and electric field conditions and all. Okay, so this is for the 3 charges. Now students, let's come to the system of 4 charges. Okay, so let's take here this one here. Here I have taken charge Q, charge Q, and here also charge Q. This is R, this is R, this is R, this is R, and here this is the center. No, so this distance will be how much here? R by root 2. All the distances will be R by root 2 here. This blue color individually. Okay. Now can you guess very well? Potential at point O will be how much here? Now see please. If you want to give the numbering also, let's take a numbering, but give the numbering always in a cyclic order. 1, 2, 3, 4 here. Okay. So due to charge Q at position 1, K into Q by this distance how much anyhow? R by root 2. R by root 2. And like this, how many configurations are there? Due to this same, due to this same, due to this same, due to this same. So we have to multiply with 4, and what this will become here? K into 4 root 2. Going correct? 4 root 2 Q by R. Okay, and anyhow we are getting here potential is not 0 here. Now after that, what about the electric field? Yes, you know very well, is it? Electric field at point O, how much? Again think please. Due to this 1, electric field is away. I am telling E1. Okay, due to this 2, electric field is away. E2, is it? Due to this 3, electric field is away. E3, and due to this 4, electric field is away. E4, and all this electric field will be same in magnitude. Directions are different, but the same in magnitude. So what will happen that here? All these electric fields will cancel out here. This will be cancelled by this one. This will be cancelled by this one. That means resultant electric field at point O, how much? 0. Potential is not 0, but electric field is 0. Is it? Good. Now students, next one, situation B. Okay. Here what I am going to take here, let's take here students here. Here I have taken Q, and then after that let's take example. Here I have taken Q, here I have taken minus Q, and here I have taken minus Q here. Now like this kind of situation I have taken here. So students, tell me please here, in this situation what will happen that here, if I talk about here, anyhow this R, no, just let me write here, and this one is R by root 2. Can you guess very well? Electric field at point O will be how much? No? Electric field also will calculate here, but first let's calculate the potential. So potential at point O will be how much here? Guess and tell. Sum of the charges how much? Sum of the charges Q minus Q, Q minus Q, how much? 0. That means potential will be how much? 0. Okay, see please here. This is 1, this is 2, this is 3, this is 4. I am doing very basic level so that everyone should understand. So what will happen that here? K into Q by R by root 2 plus due to this one, K into minus Q by R by root 2 plus K into Q by R by root 2, this one, and this one here, K into minus Q by R by root 2. Okay, that means here what is coming here? Potential is coming 0. Potential is coming how much? 0. Okay, now if I talk about here the electric field. Electric field how much will come here? 0 or non-zero? Main concern this arises. So let's see here please. This is 1. So away. E1. Now, and what is there here? Minus Q, that means towards. E2. Let me change the color actually. Now, after that, minus Q, that means away. Away or towards? Away or towards? Towards. Minus. No, so this one is coming here. What we tell here? E4. And this 3, away or towards? Away. E3. Now, can you check very well? 1 means E1 away, minus Q means E2 towards, 3 means away, and minus Q means towards here. So again, what is happening that here all this will cancel out, this cancel, this and this cancel. Let me see what is coming here. See here, electric field is also coming 0 here. Is it? Electric field is also coming 0 here. Okay students, so I hope so you have understood very well all this situation A and situation B. 2 other situations we will see that, and then we'll wrap it up here. So see here students here. Here what I have taken here students, let's take here please. Here I have taken Q, okay, and let's take previous situation what I have taken here. Let's say here I have taken Q, here I have taken Q, but now what I will take here, this Q, and here I will take here minus Q, okay, and let's take here I have taken Q, and here I have taken minus Q. See both the situation same or different? See, Q minus Q, Q minus Q, minus Q minus Q opposite, Q Q opposite. Means Q opposite, minus Q opposite. Okay, but see here what I have taken here, Q minus Q opposite, Q minus Q opposite. Okay, that means different situation. R, because configuration matters a lot. Maybe this is looking somewhat similar. You have to just see it again, then you can understand very well here. Thus configurations here. This all are how much? R by root 2. So students, can you guess very well how much potential at point O? Again, sum of the charges how much? Sum of the charges is 0. That means potential will be how much? 0 this time you have to do it. Okay, because again I'm telling, let's take here, this is 1, this is 2, this is 3, and this is 4 here. So due to this one, k into q by r by root 2, k into q by r by root 2, k into minus q by r by root 2, k into minus q by r by root 2, all will cancel out and it will come 0 here. Now, the situation arises electric field. Electric field how much here? Electric field will be how much here? At point O. Now again, let me draw here the directions. This is 1, that means positive charge, away, E1. Okay, 2, positive charge, away, E2. Now let me change the color here. And now 3, minus q, towards E3, minus 4. No, q means position 4 minus q charge. Here also how much coming here? E4. So can you see very well? E2, E4 in same direction, E1, E3 in same direction. There will not be chances to cancel out here. Anyhow, electric will be how much here? Not 0 here. Okay. Calculation you can do very well, no problem. Okay. Now students, see in this situation here. Let's take here I have taken Q, 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 and here I have taken here 2Q here. Let's take this is C situation. And now this is the D situation. Now again, this is R by root 2 as we have done here, and this is the O here. This is all R. Okay, so now guess and tell me here. Potential at point O will be 0 or non-zero. Anyhow, 0 chance not arises because all the charges are positive. Okay, so you can see very well how many charges are there. 1, 2, 3. 3Q plus 2Q, 5Q. So directly I am writing here. K into 5Q by R by root 2. That means anyhow potential is how much? Potential is non-zero here. Okay, electric field, tell me. Electric field, 0 or non-zero? Non-zero, because the charge configuration is not as symmetrical here. See here, Q, 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 but here 2Q is there. Okay, if I give the numbers also here, 1, 2, 3, 4. Let's take due to charge Q at a distance of R by root 2, electric field is E, is it? So what will happen that here, due to this one here, electric field is E, away. This is due to the electric field away, E, due to this one, electric field away, E, and due to this 2Q, electric field how much here? Away, 2E here. So you know what will happen that here? This E, this E, this E, and here out of 2E, 1E will cancel out, and what will be left? Only 1E will be left here. Again I am telling you, see, electric field will be how much here at point O in this direction. How much will be left here? E. Okay, so anyhow what is there? Electric field is not 0. Okay, so students, we have covered in case 1, 3 situations, case 2 for 3 charges, 2 situations, and for case 3, how many situations? 4 situations. So based upon that, students, you can get very well here what I have told you here. Now, this one you have to remember that here any possibility may exist.